Good afternoon. We are demonstrating the EDMS patch verification process. The EDMS patch verification process is a set of regression test scripts to be performed against EDMS itself. It is a platform that we use internally here at Meridian Integration. We use this platform in order to execute the use case scenarios in high volume iterations in order to confirm the patch before we deliver to an end client. In this example, we'll start with a series of steps. To my left, we have the EDMS patch verification process. And then to my right, we have EDMS itself. And here in the background, we actually have a PuTTY session actively connected to the EDMS server so that we can actually monitor the activity and the events. But the patch verification process is very simple in and of itself. The patch verification process starts with the settings. Here we define the EDMS user and password because everything is executed through REST interaction. That process will take place over these settings. So it uses HTTP basic authentication. So you could use your basic authenticated username and password. It must be the Meridian or equivalent super user. In this particular case here, we will point to the remote EDMS instance. This is our REST endpoint URL in our cloud. This utility is running locally on my machine, but we're connecting with our remote cloud instance of EDMS that you see here to the right. So let's click Next. As part of confirming our system setup, we will communicate with the EDMS server in order to get profile information to tell us about the EDMS instance. The EDMS instance will involve the various data sets that are configured, the various snapshot profiles that the client may have configured, and various other things. In this case right here, the data is organized as such. We pull back a list of releases from EDMS, which will allow us to organize all of the execution streams without cluttering the runtime environment. The batch thread count is a global parameter to suggest how many or to specify how many threads the submissions will run on as part of the regression test efforts. And then here at the bottom are the various environment types supported by that particular install. You can select as many as you would like that are supported in your infrastructure. In this case, if we were to choose CCNB and MDM, we could combine both. But for the sake of time, we will only refer to the CCNB 2.5 as a baseline environment for the purposes of our execution. What that means is that as we're regression testing EDMS, we will test against these various types of systems just to make sure that there were no bug or defect introduced related to a specific system that we otherwise may not have had configured in our cloud environment. So we give you everything here. In general, let's just choose this one environment, and now we're all set and we're ready to go. To submit a regression test process, you come over here and you create Submit New Regression Test. You submit your regression test and you give it a title. Here we're going to say EDMS 3.5.1.6 verification. So this will be a verification that we will be doing for this particular platform. And let's just give it P001, like execution, the initial execution. In this case, when I submit this process, this is where the magic begins. It will identify the various execution steps required by this process. It would also outline the statistics here. In this particular case here, we have kicked off this process, and over in EDMS, we will start seeing a set of automated tasks starting to happen. The very first task here is package creation. The system will create a package inside of EDMS, and that step is complete. And now it will do a baseline config extraction, which means that over here in EDMS, we will see a pending batch job over here identifying, and there we go. We are pending. So that batch job is actually running. And if we look over here in our PuTTY log, we can actually see the extract process running. For the sake of time, I will not let it complete. I will cancel it, just so that I can get control back over here. But before I do, let me cause the systems to be out of sync from my actual extraction. And I will save this. Now I've caused the system to be out of sync. Now as part of that extraction, which is now complete, the system will perform in the next regression test effort is a compare. So what we're going to do now is compare what was extracted to what is still in the system in order to confirm successful extracts. But in this particular example here, I want the compare to fail. So I've gone in and I modified the system as part of the extraction process. That will not happen in real world, but I want to show you the effects of a compare. So in this case, we're waiting for the compare process to run. If I go back to my batch jobs over here in EDMS, there goes my compare. This compare is in progress. It is comparing those items. It has reached its conclusion. So now back over in EDMS, we're monitoring that job. We were waiting, but if I click refresh, we could see that the job actually stopped. The reason why this particular job actually stopped is that we found a discrepancy, and you can actually see the discrepancy count. The discrepancy was based on the fact that I made this one change here. To get details about the discrepancies, we decided to leave that information in EDMS because EDMS gives you the detail, or the regression test tool actually gives you the detail of the particular discrepancy. So now we can see that this guy here is now complete. We marked it to actually abend once we find a discrepancy. There's no need to continue on with the other processes. But if I scroll out here to the far right, I can see this entity ID, which is my batch job ID. This batch job ID represents the batch job over here in EDMS. So if you look over here, the 108339744 represents this compare job, which is complete. If I wanted to see the details of that compare, I could drill down into that package and I could simply analyze those comparisons. And when I analyze those comparisons, I could see the various mismatches here, but I can also see that one discrepancy. Again, there's one discrepancy with that particular zone within its language. If I click on the details, you can actually see here. Okay, so again, that represents a scenario where we have such a discrepancy between how a particular patch may be affected. Again, it doesn't represent a real-world scenario as far as a pre-test is concerned. These are normally post-test activities that we would gen up such a response. Nonetheless, in that particular regard, I will move back over into the system and I will submit another regression test, and this time I will let it run normally. So in this time, I will say EDMS 3.5.1.6 P002. An arbitrary assignment once again. This time when I submit the job, it will come over and initialize the jobs the same way it did in the beginning. The only thing different this time is that I will not manipulate the data in the system. What I will do in this particular case here, I will go and monitor my batch jobs. I will cancel the extraction as soon as it starts because I don't want that much data as part of the actual demonstration because that could take a while. Nonetheless, as part of this effort here, the goal is to show you a full run and completion. So now that our extraction is underway, we will now cancel that extraction. And there goes my extraction, which is now canceled. Come back over to your regression test executor, and there you go. We are now, we're currently extracting, we're monitoring, or rather waiting. But if I click refresh, as soon as the monitor within the regression process picks up, it determines that the config job is now complete. We treat cancels as complete just to sort of accelerate the process. What is not a completion is an actual error job, and we would indicate an error as such. So what we would do is allow those processes to run to completion. That process, or those processes that are currently running, our internal poller runs every 10 seconds looking for various processes. So now that we've done our config, we're now doing a compare. In this particular case right here, you can see that we have a successful compare with no discrepancies, which means that what we've extracted actually match what's in the underlying system. So the next job that will be spawned by this process is the migration request. It's not a batch process, it's a real-time process, but this is the process in which we create a migration request for the various packages that was automatically created. So if we go into that particular package here, we can actually see that a migration request was created, and there are the details of that migration request. And that migration request requested a workflow approval, if you will. Okay. Now, with the migration request being completed, the very next step is the actual packaging and releasing. So in this case here, we can see that the system is now creating has created a release for my package, and I can see that release associated. If I drill down, I can see that my package has been assigned to that release, and I can also see, based on the activity in my package, that the system is performing various activities. Since this is a baseline config, we're not logging. Nonetheless, if I come back over to my package, my release, I see that the release has a status of deployed, my package has a status of deployed. So that's very good. It shows you that it was successfully deployed. So now my deployment activity is successful. Now it will do a post compare. After the deployment, it will go in and compare just to make sure that the deployment was successful. Once again, there's activity happening within EDMS. If I come back over here to my batch job monitor, I can actually see that a post analysis, a post compare analysis is being performed. And there goes our post config compare analysis. Looking at that information, there you go. Okay, so at this point in time, I could come back to my, my batch log screen and see if there's anything else here. Yes, so we've created a second package this time around. The purpose of this second package is to test the various snapshot profiles in our systems. Here you can see that there are 4 dynamic snapshot profiles that were picked up based on this instance of CCB25. If I come over here and I go to snapshot profiles, you can see that the metadata was picked up by the regression test module to reflect these 4 snapshot profiles. Essentially what the system is doing at this time is testing those individual snapshot profiles one by one. The first thing it's doing right here, it performed an account V extraction. So here you can see that we've literally extracted an account V, which is extremely powerful. If I drill down over here into this batch job, and I go back to this last extraction where we pull that one account, you can see that the system pulled this account in its entirety based on that snapshot profile. If you look at the package log, you can see that the system extracted this account using this condition called EDMS regression with the aforementioned snapshot profile. And now it's moving on to the FA cancel reason extraction. And there it goes right there. The beauty of the FA cancel reason extraction is using the FA cancel reason cleanup snapshot profile, which is a special snapshot profile that is used to capture everything within that domain. So you can see it's requested 17, although the input parameter was only 1. That was a special provision we picked up from one of our customers with the ability to be able to extract everything within a given domain using just an anchor tag, if you will. So you can see with the special keyword cleanup. And the very last thing it's doing right now, or the last 2 things it's doing right now, is extracting the rate schedule, which is an intensive operation because of the recursive nature of it. But once it extracts the rate schedule, and then it would extract a user portal, and then at that point in time, our process will be complete. But you can see the various extractions, the various compares, and the various deployments that took place as part of this process. So we're up to 1, 2, 3, and we're moving towards our 4th extraction, which is the user portal. So if I click refresh here, and I click refresh over here, I can see that this one's complete, and now we're at our very last one, which is the user portal. Again, clicking on this, I can see that we are extracting the user portal, going into my package. There goes my portal, successfully extracted and verified. If I click refresh, and there we go. Okay. Now, before I move on, this test process here is now complete. The status has moved to completion. The process itself is complete. It will always show up in your regression test history with regards to that particular test. This status will move to completion here just shortly. If I click refresh, it's now complete. Now with proof of concept 2, pass 2, we're now going to submit yet another regression test process. And we're going to call it EDMS 3.5.1.6, and we'll call it P006, 3 rather. The only thing different this time around is that we're referring to a related test process. The beauty of the related test process here, once I click submit, the beauty of the related test process here, and I will show you here just momentarily, but what I want to do is get back over here to EDMS and prevent a full run. For the sake of the demonstration, we cancel the extractions as soon as they begin, just to get a sampling of data to proceed. Now we're just waiting for our package creation execution script to go. There it is. And now we're waiting for our extraction. There it is. It's pending. We would take just the first few records, and then we would cancel. There, that job starting up there, and it's in progress. We've extracted already 128 objects. I will cancel this job for the purposes mentioned before. And if I come over here, I will allow the stream to run through. Now, what we will notice here that's a little differently, well, there we go here. As part of this extraction here, let's get our last updates from it. It's now complete. It shows you that we pulled 267 records. There you go, 267 records. Records remaining 291726. That's because we canceled the job. So the system is now doing its baseline compare. Okay. As a result of that compare, what we would have over here is a batch job monitor. As part of the batch job monitor, you would see that the compare is rather now moving towards completion. And now it's complete. Now, probably what I would consider one of the most exciting features here is that there's no discrepancies between this run and the last run. However, one cool feature we have here is the ability to analyze the statistics between the current run and the last run. What we mean by analyze statistics, recall that we paired this extraction process with another extraction process. So what that means is that we have execution statistics that we can compare. So here we could see that with our first run and our second run, the lapse time in respect to milliseconds is roughly the same. So it's not enough to be concerned about. There are no outliers that would stand out with regards to these particular matters here. Now we can't evaluate these yet because the job is still running and we haven't gotten to these steps. Therefore, it shows everything flatline for the current run. But in the previous run, you see the graphical area plotted here along those various sections. Likewise, the very top talks about performances. It focuses on the impact of performance, possibly by introducing a patch. The second one focuses on the quantitative nature of the data, records process, and so forth, because the records process should be the same. In this case right here, we have a variance in the records process, and again, that's understandable because I canceled the job probably at different intervals between the current run and the second run. So in reality, this would be an issue. Okay, if you were to let it run to completion and the system reported deltas, and then that would be an issue. In our case, it's not an issue because I proactively canceled the job. So with that being said, if I come back over here and refresh, we would have made further progress. We're now down to the compare. And now if I look at my statistics chart, you can see a little bit more maturity here, if you will. Okay, so it correlates better between the first and the last. So our counts are relatively, just varying in the difference of the amounts that we had talked about here. The performance is relatively spot on between the first iteration and the second iteration, which is a promising sign. So normally what represents a first iteration and a second iteration is the before and after. You would run the regression test against an environment first, you will apply the meridian patch, and then after that you will run those same tests again, and the net result should be the same. So that's what you're going for, and that will represent the stream of activity that goes with a particular execution. Okay, now having said that, that will conclude what we have here. If we go back down and we look at the very bottom, you can see that this job is now wrapping up. We've extracted our account. Reflective over here, if you look, we've extracted that account immediately following the compare and the package creation. So if I come over here and I look and I go into that package, once again, there goes my account, and there's all of the complexities, all of the data, it's captured right there for you. Okay, now again, the rate schedule takes a little while because of the recursive nature, but there goes our FA cancel reason using the special profile. And here we have it. It now appeared. And the list goes on and on and on. Very excited to present this and excited to release this to our customers. And it would be useful for those particular regression test processes in order to make it your own. Thank you for your time.